The learning objectives for Chapter 9 are as follows: to list and briefly explain the functions of water in the body, to classify the minerals as major or trace minerals, to list conditions of the body, dietary factors, and other pertinent relationships that influence the absorption, retention, and availability of specific minerals, to list key functions, deficiencies, and toxicities in at least two food sources of the major and trace minerals, to explain the role of nutrition in maintaining a healthy blood pressure, and to describe the processes involving minerals that aid in maintaining bone health and preventing osteoporosis. We can't discuss minerals without first recognizing the importance of water, since minerals exist in the body dissolved in water. Water makes up about 50 to 70% of our body weight and has many functions, including body temperature regulation, removal of body wastes, and it's a component of amniotic fluid, your saliva, bile, and it acts as joint lubrication. Now, the recommendation for women is to consume about 9 cups of water per day, and for men, 13 cups per day. Body water is divided into two basic compartments: intracellular and extracellular. Now, intracellular fluid is water within the cells and accounts for about 65% of total body fluid, while your extracellular accounts for about 35%. The extracellular fluid is found in the intravascular fluid, or water in the bloodstream, the interstitial fluid, and glandular secretions. For optimum health, there must be homeostasis, and for this to exist, the body must be in fluid and electrolyte balance. So this means that water lost through urination or through perspiration in the respiratory tract must be replaced in both terms of volume and electrolyte content. So how is your electrolyte content controlled? Through osmosis, which is where water moves from the side of the cell with lesser amount of solute to the side with a greater solute concentration. And potassium is the principal electrolyte in intracellular fluid, while sodium is the principal one in the extracellular fluid. And when electrolytes in the extracellular fluid are increased, the intracellular fluid moves to the extracellular in an attempt to equalize the concentration of electrolytes on both sides of the cell membrane. Now, this movement reduces the amount of water in the cell, and when the sodium in the extracellular fluid is reduced, water flows from it into the cells. Now, most of you have probably studied osmosis in a different class, so you're probably quite familiar with this concept. But this slide shows the effect of ion concentration on red blood cells. So in the first picture labeled A, a dilute solution with a low concentration of ions results in swelling and then rupture of the cell. In B, the concentration on either side of the membrane is equal, resulting in normally shaped red blood cells. Finally, in C, a solution that is concentrated with a high ion concentration causes water to leave the cell, resulting in a shrunken cell. And this is why fluid and electrolyte balance is vital for life. Okay, so think about when you feel thirsty. Do you think that this is a reliable way to know that your body needs water? Well, no, it's not necessarily the best way, since the thirst sensation often lags behind the body's need for water, especially in the elderly, children, athletes, and those who may be ill. Dehydration can occur if there is inadequate water intake or abnormal loss, and this can occur due to several factors. But if you have diarrhea or vomiting, if you have severe burns or have diabetes or excessively when the cells of the body become dehydrated, the hypothalamus stimulates the pituitary gland to excrete an antidiuretic hormone. whenever the electrolytes become too concentrated in the blood. Now, this excretion causes the kidneys to reabsorb water rather than secrete it. And when this happens, the thirst mechanism comes into play. It causes us to want to drink. Now, when the sodium in the extracellular fluid is reduced, water flows from the extracellular fluid into the cells. When this happens, the adrenal glands secrete aldosterone, which triggers the kidneys to increase the amount of sodium reabsorbed. When the missing sodium is replaced in the extracellular fluid, the excess water that has been drawn from the extracellular fluid into the cells moves back to that fluid, relieving cellular edema or swelling of the cells. Now, when you lose 1 to 2% of your body weight in fluid, the thirst signal will begin. And if you lose 20% of your body weight in fluid, it could result in coma or. Now, on the other hand, there is such a thing as it is taking in too much water. And consuming too much water can dilute the blood electrolytes, especially sodium. And too much water can overwhelm the kidneys, which can lead to blurred vision, actually. And moving on to minerals, chemical analysis reveals that the human body is made up of specific chemical elements. Oxygen, carbon, hydrogen, and nitrogen make up about 96% of body weight. All the remaining elements are minerals, which represent only about 4% of body weight. However, these minerals are necessary for good health. And if you recall, a mineral is an inorganic element necessary to build tissues. It also they help regulate body fluids and assist in other various body functions. And minerals are divided into two groups. The major minerals are required in amounts greater than 100 milligrams per day, and the trace minerals are needed in amounts smaller or less than 100 milligrams per day. This graph taken from your text shows the approximate amounts of minerals present in most people. Some of the trace minerals are not listed here, but you can see that calcium by far is the mineral present in the highest amounts in our bodies, since it makes up our bones and strengthens our teeth. Now, although we consume many minerals each day as we eat, there are several factors that actually influence the degree to which we can absorb and use those minerals. This is termed bioavailability. For instance, as the text describes, although spinach contains large amounts of calcium, only about 5% is absorbed. This is due to a compound that's also in spinach called oxalic acid. Now, I was able to find a reference that stated that you would have to eat more than 16 cups of raw or more than 8 cups of cooked spinach to get the same amount of calcium available in 1 cup of yogurt. And that really surprised me. Now, generally, minerals are absorbed better from animal products than plant products because there are no fibers present to bind minerals, which could inhibit absorption. Another factor that influences bioavailability is the soil that the plants are actually grown in. And it depends on what type of minerals the plants take up from the soil. Foods that are refined are also much lower in mineral content than the natural foods in the unprocessed state. And minerals can also interfere with each other, and vitamins can interfere with mineral absorption as well. Now, because it's known that minerals are essential to good health, some people think that more is better. Ironically, if you consume too many minerals, this can be hazardous. In a healthy person who's eating a balanced diet, there will be some mineral loss through regular perspiration in the saliva, and those that are consumed in excess of what the body needs are excreted through the urine and feces. However, when concentrated forms of minerals are taken on a regular basis, over time they become more than the body can handle, and toxicity can develop. And sometimes this causes a deficiency of another mineral. Also, excessive amounts of minerals can cause hair loss, changes in the blood, hormones, bones, muscles, and nearly all tissues. Now, trace minerals are more toxic at high levels since they're only needed in small amounts by our bodies. And some supplements can be contaminated, so if you do consider taking mineral supplements, brands that are approved by the U.S. Pharmacopoeia lessen the safety risks. In this presentation, I will share slides on major and trace minerals, but I'm only choosing 3 major minerals to discuss, and this will include sodium, potassium, and calcium. Now, the other minerals should be reviewed as they will be included on test 3. So the first major mineral we will go over is sodium. This is an electrolyte whose primary function is the control of fluid balance in the body, and it's a main component of table salt and is also naturally present in foods of animal origin. Fruits and vegetables contain little or no sodium. So our bodies absorb almost all of the sodium that we consume, and as mentioned earlier, the hormone aldosterone regulates sodium balance. Sodium is also key for retaining body water, and its excretion is regulated by the kidneys. Sodium ions assist in nerve impulse conduction and in nutrient absorption. Sodium deficiency is quite rare because we consume a good bit of it in our diets. Only if you have a diet low in sodium combined with excessive sweating or are ill with vomiting and diarrhea symptoms could you be at risk for a deficiency. Deficiency can actually lead to further vomiting, nausea, muscle cramps, and later even coma. So why is a deficiency generally rare? So think about the following sources, and some are not necessarily ones you would think about. For instance, sodium is found naturally in some foods, and it's added for taste in others. It's used for preservation, especially in processed foods such as chips and French fries and deli meats. It's also added to foods for function's sake, such as in the form of baking soda or sodium bicarbonate. Other food sources of sodium include salt added at restaurants, and that's a major problem. There is so much sodium added to foods in restaurants and by food manufacturers. It's also found in milk and dairy products and processed foods such as store-bought pies, as I mentioned before, potato chips, and soups. There's a lot of salt in canned soups, deli meats, and salad dressings, just to name a few. Now remember, the sodium content of foods is required to be on food labels, so you can always look at it when you're grocery. So the adequate intake for adults under age 51 is 1,500 milligrams per day, while we only need about 200 milligrams for proper body function. And the upper level for sodium is 2,300 milligrams per day. And recall that the upper level is the highest amount of a nutrient unlikely to cause adverse health effects. And the daily value on food labels is set at 2,400 milligrams. Now, with that in mind, the typical sodium intake in the U.S. is 4,700 milligrams per day. When you complete your the semester project, you will probably be surprised at how much sodium you consume. And I know I was very surprised when I did this exercise myself. Now, the more processed foods you consume, the higher it will likely be. Now, the second major mineral is potassium, which is the positive ion in intracellular fluid. It functions similarly to sodium in fluid balance and nerve impulse transmission. Now, unlike sodium, potassium is associated with lowering blood pressure, and about 90% of the potassium we consume is absorbed. Now, if you consume very low amounts of potassium, you may experience symptoms such as muscle cramps, confusion, even constipation, possibly irregular heartbeat, and the worst case scenario would be heart failure. Potassium is found in many foods that we eat, especially fruits like oranges, bananas, and peaches, and vegetables like mushrooms, Brussels sprouts, potatoes, tomatoes, lima beans, and carrots. And some meats also provide potassium, but fruits and vegetables are the main source. Now, the adequate intake is 4,700 milligrams per day, and the daily value is set at 3,500 milligrams per day. Typical intake averages around 2,000 to 3,000 milligrams per day, but we really don't have to worry about excess because it's excreted by the kidneys, so there's no upper level, and people don't generally add potassium to food like they do sodium, so it's not as much of a concern. So moving on to calcium, more than 99% of the calcium in our bodies is used for bone and teeth strengthening. And the remaining 1% is in our blood. Calcium makes up about 40% of all the minerals in our bodies. And as for absorption of calcium in the body, the amount of calcium depends on how much we absorb from the foods that we consume. Now, to be absorbed, calcium relies on the acidic environment of our GI tract and the presence of vitamin D. We normally absorb about 25% of calcium from the foods we eat, but this can be greatly increased during time of need to as much as 60% during pregnancy and infancy. What types of factors influence calcium absorption or decrease its absorption? Well, anything that causes increased intestinal motility, such as laxatives or having diarrhea, because these move substances through the intestine very rapidly, not leaving enough time for calcium to be absorbed. Fiber can bind calcium in the intestine and decrease absorption. And both phosphorus and calcium require vitamin D for absorption. In foods like whole grains, soft drinks, and peanut butter that are high in phosphorus can cause competition with calcium-rich foods for vitamin D, and this can cause calcium to be lost. Another factor is vitamin D deficiency. It can cause calcium malabsorption. Tannins in tea can bind with calcium in the intestine, which can also decrease absorption. And finally, menopause. As estrogen drops during menopause, so does calcium absorption, since estrogen plays an important role in increasing calcium absorption. Calcium has several important functions in the body, with the most important being bone formation and maintenance. And it's critical in blood clotting. And if calcium levels fall too low, muscles can't relax after contraction. Calcium is also vital to nerve impulse transmission and in the regulation of cell metabolism. Calcium influences enzyme and hormone activity during cell metabolism. In North America, about 75% of the calcium that we absorb is obtained from dairy products such as milk, yogurt, and cheeses. Now, leafy greens are a good source of calcium, but as I mentioned earlier, calcium from spinach is often not absorbed due to the oxalic acid in it. And the recommended daily allowance ranges from 1,000 milligrams to 1,200 milligrams per day for adults. So we can't leave a discussion on calcium without discussing the relationship with bones. Now, the strength of your bones is dependent on your bone mass and bone mineral density. And the more bone you have, the stronger the bone. And as a child, then on through young adulthood, you're consistently building bone until you reach your peak bone mass. This bone mass seems to represent the major element of your bone mass in your later adult years. And some studies performed on postmenopausal women indicate that a lifetime of calcium intake was associated with reduced risk for osteoporosis. And there's a terrific section in the back of chapter 9 about osteoporosis, and I highly encourage you to read this.